Have you ever stopped to wonder what magic goes into your favorite chocolate treat? Imagine a world where science, technology, and a dash of passion come together in a colossal, buzzing hub of creativity. Welcome to the mega factory where the legendary KitKat is born. Today, we're taking you on an exclusive behind-the-scenes tour of how these irresistible chocolate bars are made. So grab your favorite break time snack and join me as we unravel the fascinating journey from raw ingredients to that satisfying snap of a perfectly crafted KitKat bar. Stepping into this mega factory is like entering a universe of innovation and precision. Every inch of this vast facility is dedicated to one mission: creating the iconic KitKat, a treat enjoyed by millions around the world. Let's start our journey at the very beginning: the raw materials. Every great product begins with the finest ingredients. At the heart of KitKat's delicious taste is a careful selection of raw materials. Here at the factory, shipments of cocoa, sugar, dairy, and specially formulated wafer ingredients arrive daily. Imagine vast silos and specialized storage rooms, each meticulously monitored to ensure that only the best raw materials are used in production. When these ingredients first arrive, they undergo rigorous quality checks. Skilled technicians examine the cocoa beans, checking for aroma, texture, and even a hint of that natural bitterness that only the best beans possess. Meanwhile, milk and sugar are tested to ensure they meet the strict standards required to produce smooth, velvety chocolate. This initial phase is critical. It's where quality is built from the ground up, ensuring that every single KitKat bar is a testament to excellence. You see, in this factory, quality isn't just a buzzword. It's the lifeblood of every process that follows. Once the raw materials are approved, it's time to dive into the art and science of chocolate making. The journey of transforming cocoa into the rich, creamy chocolate that envelops the KitKat begins in a large mixing area. Here, cocoa, milk, and sugar are combined in precisely measured proportions. The secret lies in the blend. Every ingredient plays its part to create that unmistakable taste. The mixture then moves on to a refining stage, where it's ground to perfection. Imagine a series of giant rollers and state-of-the-art grinders, turning gritty cocoa particles into a silky smooth paste. This process not only refines the texture, but also releases the deep, complex flavors locked inside the cocoa. After refining, the chocolate must be tempered, a delicate process of heating and cooling that gives the chocolate its shiny finish and satisfying snap. In the tempering room, precise temperature controls ensure that the chocolate crystals form in just the right way. It's a bit like orchestrating a symphony where every note must be perfectly in tune. The result? A glossy, robust chocolate that not only tastes incredible but also looks as good as it feels. Seeing the chocolate transform from a thick paste into a smooth, glossy masterpiece is nothing short of mesmerizing. Now, let's shift our focus to another key element of KitKat: the wafer. The wafer is what gives KitKat its signature crunch and light, airy texture. In a separate wing of the factory, skilled workers oversee the production of these delicate, crispy layers. The process begins with a specially formulated batter. This isn't your ordinary cake mix, it's engineered to achieve the perfect balance of crunch and tenderness. The batter is carefully poured into large industrial ovens where it bakes to golden perfection. The heat transforms the batter into a crisp yet flexible wafer that's strong enough to support the layers of chocolate that will soon envelop it. Once baked, the wafers are sliced and shaped with remarkable precision. High-speed cutters and rollers work in tandem, creating the uniform segments that we all know and love. Every wafer is a marvel of engineering, thin enough to let the chocolate shine through, yet sturdy enough to provide that satisfying snap when you take a bite. Every step in the wafer-making process is designed to ensure consistency, so that whether you're enjoying one KitKat bar in Tokyo or New York, the crunch remains just as delightful. Here's where the magic truly happens: the assembly line. In one part of the factory, two streams converge, one carrying the perfectly tempered chocolate and the other delivering the freshly baked wafers. It's a finely tuned dance of precision and timing. At the assembly station, the wafers are carefully laid out on a moving conveyor belt. The next phase involves a process called enrobing, where the wafers are dipped or sprayed with a generous layer of chocolate. The machines here are marvels of modern technology. They move at incredible speeds while maintaining a level of accuracy that would make any watchmaker proud. As the chocolate cascades over the wafers, it's important that every inch is evenly coated. Robotic arms and sensors work together to ensure there are no gaps. Every KitKat bar must meet the high standards that fans around the world expect. You might notice that the chocolate appears to form a smooth, continuous shell, but there's a science behind that. The flow of chocolate is controlled by both temperature and viscosity, making sure that it hardens just right once it leaves the machine. This stage of production is a perfect example of how technology and craftsmanship come together in harmony. Every wafer is transformed into a work of edible art. After the wafers are enrobed in chocolate, they must go through a cooling process. In a specially designed tunnel, cool air circulates around the bars, helping the chocolate to set and achieve its signature snap. It's a delicate balance. The chocolate must harden just enough to protect the wafer inside while still retaining that irresistibly smooth texture. Once cooled, the continuous chocolate-covered wafer is fed into precision cutting machines. These machines slice the long ribbon of KitKat into individual bars. Each bar is scored into segments, typically 4 distinct fingers that can be snapped off with that iconic break. The cutting process is incredibly precise, ensuring that every piece is uniform in size and shape. During this stage, you can almost hear the crunch even before the bar is unwrapped. It's the sound of engineering and passion coming together to create a product that's more than just a snack. It's an experience. Every step, from cooling to cutting, is executed with meticulous care. It's what makes the difference between a good chocolate bar and the unforgettable taste of a KitKat. No factory would be complete without a rigorous quality control process, and here, quality assurance is taken very seriously. Every batch of KitKat bars undergoes multiple tests to ensure that each one meets the high standards synonymous with the brand. In dedicated quality control labs, technicians sample bars from different production runs. They check for consistency in texture, taste, and appearance. Does the chocolate have the right gloss? Is the wafer crisp enough? These are questions that are answered with both scientific instruments and good old-fashioned taste tests. Sometimes a tiny adjustment in temperature or mixing time can make all the difference, so the team is always on alert. There are also automated systems in place. High-speed cameras and sensors scan the bars as they move along the production line. Any bar that doesn't measure up, be it a slight misalignment or an uneven chocolate coating, is immediately flagged and removed. This commitment to quality is what has helped KitKat maintain its reputation as a premium treat for decades. It's not just about meeting a standard, it's about exceeding expectations every single day. Each KitKat bar that leaves this factory is a promise of quality, crafted with care and precision. Once the bars have passed the stringent quality tests, they move on to the final stage of the journey, packaging. This part of the process is a blend of high-speed automation and human attention to detail. The bars are conveyed to packaging lines where they are wrapped in the familiar red and white foil that you instantly recognize. The packaging process is designed to protect the bars during transport while also capturing the brand's fun and vibrant personality. Each KitKat is individually wrapped, and then several bars are boxed together. It's a testament to both technology and design, ensuring that every package not only preserves the freshness and taste of the chocolate, but also delights the consumer with its presentation. At this point, a final inspection is conducted. Workers and automated systems check the packaging for any defects, making sure that every piece meets the brand's high standards. It's the last step before the bars are shipped off to stores and distributors around the world, ready to bring a little moment of joy to someone's day. From the moment raw ingredients are delivered to the final package being sealed, every stage of production is carefully choreographed to create a product that millions have come to love. But it's not just the machines and technology that make KitKat special, it's the people behind it. Throughout the mega factory, you'll find dedicated workers who take pride in every detail of the process. From engineers fine-tuning the machinery to quality control specialists ensuring that each bar tastes just right, every team member plays a critical role in the creation of this beloved treat. There's also a strong sense of innovation here. The factory is continuously evolving, adopting new technologies and methods to improve efficiency and quality. Whether it's through state-of-the-art automation or by harnessing the latest in food science, the spirit of innovation drives every decision. It's this blend of human creativity and technological prowess that makes the process so fascinating.
Unwrapped a Snickers bar and thought about all the magic behind its irresistible blend of nougat, caramel, crunchy peanuts, and smooth chocolate? Today, we're going behind the scenes at one of the world's most sophisticated candy factories to see how this beloved treat is made. Trust me, by the time you finish this tour, every bite of your next Snickers will taste even better knowing the care, precision, and technology that goes into making it. Welcome to the heart of the action, a sprawling factory where state-of-the-art machinery meets artisanal craftsmanship. Here, ingredients from around the globe are transformed into one of the most iconic candy bars on the planet. Let's dive into the process, step by step. It all starts with the basics. At the beginning of every day, high-quality raw materials are delivered to the factory. This isn't just any batch of ingredients. Each component is carefully sourced to meet strict quality standards. The cocoa, for instance, comes from premium plantations known for their rich, robust flavor. The peanuts are roasted to perfection to ensure they add just the right crunch, and the sugar and milk are of the finest grade available. Every ingredient is checked for quality before it even makes it onto the production line. This meticulous selection process guarantees that every Snickers bar you enjoy is made with the best starting materials possible. It's a lot like cooking your favorite recipe. If you start with great ingredients, the final dish will always be a treat. Now, let's talk about the heart of the Snickers bar, the nougat. Making nougat isn't just about mixing a few ingredients together, it's a carefully choreographed process that requires precision and timing. The base of the nougat is a blend of sugar, egg whites, and a hint of flavoring. These ingredients are whipped into a frothy, airy mass that forms the perfect canvas for the later layers. As the mixture whips, it gradually transforms into a light, fluffy substance that's almost like edible cotton candy. This step is crucial because it sets the stage for the subsequent layers of caramel and peanuts. The technicians constantly monitor the texture and temperature, making sure that the nougat is just right before it moves to the next stage of production. Next up is the caramel. Rich, buttery, and perfectly gooey. Caramel is created by carefully heating sugar and milk with a touch of butter and vanilla until it reaches that ideal consistency and flavor. This step is as much about art as it is about science. The mixture is cooked at precise temperatures to achieve that perfect balance between liquid smoothness and a texture that can support the peanuts later on. This isn't a haphazard process. Experienced chefs and automated systems work side by side, ensuring that every batch of caramel has the same deep, indulgent flavor that makes Snickers so satisfying. The caramel is then cooled just enough to be spread over the nougat, creating a layer that's both sweet and slightly chewy. With our nougat and caramel ready, it's time to assemble the Snickers bar. Picture a well-orchestrated assembly line where every move is timed to perfection. First, the soft nougat is spread onto a moving belt. Then, the warm, luscious caramel is gently poured over the nougat, creating a harmonious layer of sweetness. At this point, roasted peanuts are scattered evenly over the caramel. These peanuts aren't just added randomly. They're carefully measured to ensure that every single Snickers bar gets that perfect crunch in every bite. The mixture is then pressed into shape. Each bar is formed to be consistent in size and texture, so whether you grab one from a vending machine or a candy store, you know you're getting the same great experience. The precision of this process is impressive. Automated machinery works seamlessly with human oversight, ensuring that the layers remain distinct, yet perfectly integrated. This balance is what makes the Snickers bar so unique, a blend of textures and flavors that come together to create an unforgettable taste. The next stage is perhaps the most visually appealing, enrobing the bars in chocolate. Imagine a river of molten glossy chocolate flowing along the production line as each assembled bar passes through. It's dipped or drizzled with this luxurious chocolate, which cools almost instantly to form a smooth, hard shell. This chocolate isn't just any coating, it's carefully formulated to complement the flavors inside while providing that satisfying snap when you bite into it. The chocolate coating seals in the freshness of the caramel, nougat, and peanuts, and gives the Snickers bar its irresistible finish. During this phase, quality checks ensure that every bar is uniformly coated without any excess or missing patches. Quality is paramount at every stage of production. After the chocolate coating, each Snickers bar undergoes a series of rigorous quality control tests. Automated sensors and human inspectors check for consistency in weight, size, and texture. Any bar that doesn't meet the high standards is set aside for further examination. This attention to detail is what ensures that every Snickers bar that reaches your hands is nothing short of perfect. Once the bars pass inspection, they move on to the packaging area. Here they are individually wrapped in that signature easy-to-peel foil that not only keeps the chocolate intact, but also locks in the freshness of all the layers. The packaging process is a blend of high-speed automation and careful human touch. Each package is sealed, labeled, and boxed with precision, ready for distribution across the globe. You might be wondering, what makes this entire process so efficient and consistent? The answer lies in the cutting-edge technology used throughout the factory. From computer-controlled ovens that maintain precise temperatures during the caramel cooking process to robotic arms that delicately handle the chocolate coating, every machine is designed for perfection. At the same time, experienced technicians and quality control experts are always on hand to monitor the process. This blend of advanced technology and human expertise is what ensures that each Snickers bar not only meets but exceeds customer expectations. It's a reminder that behind every great product is a perfect marriage of science and art. But it's not just about making a delicious candy bar. There's also a strong focus on sustainability and innovation. Modern factories are increasingly adopting eco-friendly practices. At the Snickers production facility, energy-efficient machines and waste reduction protocols are in place to minimize the environmental footprint. Recycling programs ensure that any excess materials or byproducts are repurposed responsibly. Innovation is at the core of every process improvement here. Engineers are continuously working to refine production techniques, making sure that every Snickers bar is made not only with the utmost quality, but also with a keen eye on sustainable practices. This commitment to innovation and environmental stewardship is one of the many reasons why Snickers remains a favorite across generations. After a journey that involves precision, technology, and a touch of culinary magic, the final Snickers bar emerges perfectly layered, impeccably wrapped, and ready to delight your taste buds. Every bar is a testament to the skill and dedication of the people behind its creation. It's a product that has been carefully crafted from start to finish, ensuring that each bite is a perfect blend of textures and flavors. Whether you're grabbing one on the go or savoring it as a special treat, each Snickers bar carries with it the story of a journey from raw ingredients to a masterpiece of confectionery art. So next time you unwrap a Snickers bar, take a moment to appreciate the journey behind it. From the careful selection of the finest ingredients to the precision of high-tech machinery and the dedicated hands that ensure every step is perfect. It's a process that's as much about quality and innovation as it is about creating a snack that you love. In our fast-paced world, it's easy to take our favorite treats for granted, but behind every bite of a Snickers bar is a story of passion, precision, and a relentless pursuit of perfection. And isn't that something worth savoring?
Hey there, folks. Ever popped open a cold can of Pepsi and wondered, how in the world does this sweet, fizzy masterpiece make its way from a massive food processing factory right into my fridge? Well, you're in luck, because today we're diving headfirst into the amazing food processing journey of Pepsi. Get ready to see how advanced technology, high-speed machines, and a dash of American hustle all come together to create one of the world's most iconic soft drinks. By the time we're done, you'll have a whole new appreciation for every refreshing sip. Before we crack this can wide open, I gotta ask a little favor. Smack that like button, drop a comment, and subscribe to this channel if you love exploring incredible food factory processes and behind-the-scenes looks at how some of your favorite treats are made. It really helps us keep the lights on, the cameras rolling, and the fizz going strong. Now, let's rewind the clock to the late 19th century, when Caleb Bradham, a North Carolina pharmacist, whipped up a special concoction he first called Brad's Drink. It was meant to give folks a tasty pick-me-up on those sweltering southern days. Little did he know, that humble experiment would evolve into what we call Pepsi. Over the years, Pepsi has undergone countless recipe tweaks, marketing campaigns, and branding shifts. And while it's certainly had its fair share of good-natured rivalry with other colas, Pepsi has carved its own loyal fan base in the good old US of A. In the early days, production was far from the high-tech wonder we see now. Mixing syrups and carbonated water often took place in smaller bottling plants or soda fountains. Sometimes, folks made it by hand with simple mixing equipment. But as demand soared, so did the scale. By the mid-20th century, Pepsi had become a major household name, with factories all across the country upgrading to more automated, modern machinery. Fast forward to the present day, and Pepsi's process has turned into a truly state-of-the-art operation, powered by advanced sensors, lightning-fast conveyor belts, and giant stainless steel tanks that look like they're straight out of a sci-fi movie. So how do we get from plain old water to that vibrant fizz we love? The journey begins at the water purification station, often called the process zone. Most Pepsi factories source water from local municipalities or wells. But simply grabbing water from the tap or a well won't cut it in the food processing industry. It needs to be meticulously filtered and sanitized to meet Pepsi's stringent purity standards. First up is filtering out any unwanted particles, things like sediment or small debris. This is usually done with a series of filters that can catch particles invisible to the naked eye. Next, the water passes through activated carbon filters to remove any funky odors or tastes. After that, the water heads into a reverse osmosis system, which pushes it through a semi-permeable membrane at high pressure, removing any dissolved solids or contaminants. Finally, it might go through ultraviolet UV treatment, which uses UV light to zap any lingering microbes. Only then does the water earn its ticket to the big leagues, joining the specialized mixing tanks. This rigorous approach ensures each sip of Pepsi has that consistently smooth, crisp taste people have come to expect. Now that the water is pristine, it's time to talk about the sweet stuff. Pepsi's sweetness typically comes from high fructose corn syrup, cane sugar in some variants, or sometimes a combination of both, depending on the region or product line. These sweeteners don't just show up in a simple bag. In a modern food factory, you'll often see massive tankers pulling in, pumping sweetener through intricate hoses directly into holding tanks. Next, we have the carefully guarded flavor essence, an aromatic and flavorful syrup that gives Pepsi its signature taste. This special syrup is kept under lock and key. Only a few folks know the complete recipe. If you've ever wondered why Pepsi tastes just slightly different from other colas, you can chalk it up to that top secret formula. Inside the mixing area, advanced food processing machines use automated systems to measure out the exact ratios of sweetener, water, and flavor base. This isn't guesswork either. Sophisticated sensors monitor temperature, consistency, and flow rates, making real-time adjustments if something's even slightly off. Think of it like a giant super precise kitchen where automation is the head chef. Giant stainless steel vats that sparkle under powerful LED lights. This is where the real magic happens. The process typically starts by pumping in the filtered water, followed by the sweetener. Then, the flavor essence gets introduced at just the right moment. Too early, and it might lose some of its potency. Too late, and it won't blend well. Throughout this blending process, big industrial paddles or agitators spin inside the tanks, ensuring every molecule of flavor is evenly distributed. Temperature control is paramount here. If it's too warm, you risk damaging the flavor. If it's too cold, you might have trouble dissolving sweeteners. Factories often use computerized control panels that track temperatures, pressures, and flow rates 24/7, almost like a backstage conductor for an orchestra of food machines. Some modern plants even use digital refractometers to measure the Brix level, essentially the sugar concentration. If that reading isn't right where it needs to be, the system can automatically add more water or more syrup to keep the taste consistent. After the blending is spot on, it's time to introduce the star of the show, carbonation. Most folks don't realize how intricate the carbonation step can be in a processing factory. Carbon dioxide, CO2, is stored in hefty pressurized tanks that look like futuristic capsules. A specialized carbonation system injects CO2 into the mix at controlled rates, balancing pressure, temperature, and time to create that satisfying fizz. The environment in this carbonation zone can be quite chilly because lower temperatures allow the water to absorb more CO2. Modern Pepsi factories use advanced chillers and computerized valves to maintain the precise temperature needed. If this process is rushed or not handled properly, you'll end up with soda that's either overcarbonated and prone to foaming over when opened, or undercarbonated and disappointingly flat. To prevent mishaps, technicians continually test samples using specialized meters that gauge CO2 content. When everything's just right, you can practically hear that crisp, refreshing hiss echoing through the stainless steel hallways. Still with me on this fizzy adventure? If you're enjoying this deep dive into Pepsi's modern factory process, go ahead and hit that like button, comment below, and if you haven't already, subscribe for more behind-the-scenes peeks at America's favorite food factory operations. Your support helps us uncover even more cool processes, so thanks y'all. Once the soda is perfectly carbonated, it's ready to meet its container, be it a bottle, can, or fountain syrup bag. Let's talk about cans and bottles first. You've probably seen videos online of those crazy fast conveyor belts zipping hundreds of bottles every minute, right? In a Pepsi plant, these lines can be truly mesmerizing. Plastic or glass bottles often come in pre-formed or are blow molded on site, while aluminum cans arrive stacked and ready to go. High-speed filling machines do the heavy lifting, dispensing Pepsi into bottles or cans with incredible precision. Each filler head aligns perfectly with a container's mouth, ensuring minimal spillage or overflow. Meanwhile, advanced sensors check fill levels, detecting even the tiniest discrepancies. If something's off, a leaky nozzle or a misaligned can, the line will stop automatically to let technicians fix the issue. With a process this streamlined, it's no wonder they crank out thousands of Pepsi bottles and cans per hour. Once filled, containers move down the line to be sealed or capped. Bottles get tamper-evident caps, while cans get aluminum lids seamed on with specialized sealing machines. This is a critical juncture in the food processing industry. A sloppy seal means lost carbonation or contamination. Some factories incorporate robotic arms outfitted with cameras to ensure each container is properly sealed, while others rely on laser-guided capping systems. Either way, it's a beautiful dance between man and machine. Up next is labeling, an essential part of any product's marketing identity. The now capped bottles or sealed cans glide through a labeling machine, where they're quickly adorned with that familiar Pepsi logo, nutritional info, and any promotional material. Automated sensors check for alignment, making sure each label is straight and wrinkle-free. One tiny misalignment can cause thousands of mislabeled products, so the margin for error is practically zero. Then comes the packaging phase, where individual bottles or cans are grouped into packs, trays, or multi-packs. Big mechanical arms or rotating carousels arrange them into neat rows before they're shuttled into cardboard cases. From there, another machine swiftly seals the boxes, preparing them for shipping. This entire workflow, filling, capping, labeling, and boxing, can happen in such a rapid-fire sequence that it's almost too fast to track with the naked eye. It's a testament to how far processing factory technology has come over the decades. No talk about a modern Pepsi factory is complete without mentioning the rigorous quality control steps. Random samples of Pepsi are pulled off the line at regular intervals. Quality control technicians measure carbonation levels, check the sweetness, and even do taste tests. Some factories have dedicated labs right on site, where a small group of trained tasters sips different batches and scores them based on flavor, aroma, and consistency. In addition, advanced camera systems scan bottle labels and fill levels. If a sensor detects a product underfilled by even a fraction of an ounce, it triggers a pneumatic arm to knock that bottle off the line. Factories have also adopted digital scanning to confirm that batch codes, expiration dates, and barcodes are printed clearly. This quick scanning helps identify issues in real time, saving thousands of products from hitting the shelves flawed. Pepsi also strictly adheres to Food and Drug Administration (FDA) standards, ensuring every bottle that leaves the facility is safe and consistent for American consumers. Once each bottle or can gets the green light, they head over to a sprawling warehouse area where giant racks hold pallets stacked with case after case of Pepsi. Advanced forklifts, sometimes guided by digital tracking systems, move these pallets around with efficiency and speed. In some high-tech plants, automated guided vehicles, AGVs, shuttle products to designated spots without a driver, using sensors to navigate. From there, it's time to load trucks and ship out to various destinations: grocery stores, stadiums, movie theaters, or anywhere else Americans thirst for a cold Pepsi. Some products travel mere miles to a nearby distribution center, while others trek halfway across the country. Either way, the journey is tracked meticulously, often with GPS monitoring, to ensure timely arrivals. This distribution network is a critical piece of the puzzle, linking the advanced world of food processing technology to everyday consumers. Like many giants in the food industry, Pepsi is looking toward a future where eco-friendliness is a key priority. Factories now adopt water-saving measures, energy-efficient machines, and more sustainable packaging solutions. You might see more recycled content in the plastic bottles, or you might notice that aluminum cans are made lighter to reduce material usage. All these steps reflect a growing trend in the food processing industry, where large-scale brands aim to maintain that balance between profitability and stewardship of natural resources. Innovation doesn't stop at sustainability, though. Factories are constantly testing out new flavor lines, sugar alternatives, or health-focused variations to keep up with changing consumer tastes. They also invest heavily in advanced robotics and data-driven analytics to spot production inefficiencies. Some plants even use real-time monitoring software that can predict when a machine might fail, allowing for preventative maintenance before any major downtime happens. It's mind-blowing to think how far we've come from those early days of hand-mixed soda in small bottling shops. And there you have it, folks, the complete journey of how Pepsi is made in a modern factory filled with advanced technology. From meticulous water purification and sweetener selection to high-speed bottling, labeling, and beyond, every stage is a fascinating blend of tradition, science, and innovation. If today's peek behind the curtain left you thirsty for more knowledge about the incredible world of food processing machinery and American manufacturing,
welcome to our behind-the-scenes look at one of America's favorite tropical snacks, banana chips. Ever wonder how these crunchy slices go from tall banana plants under the hot sun all the way to a sealed bag on your store's shelf? Today, we're diving into a mega food processing factory that churns out millions of banana chips using cutting-edge machines and old-fashioned know-how. Most bananas destined for chips come from big plantations in warm, humid climates. Farmers keep track of when the bananas are ripe enough to ensure sweetness, yet firm enough to survive the journey. They carefully cut down large bunches, called hands, which can weigh several pounds each. The bananas are rinsed to remove field dirt. Sorted so that only the right shapes and sizes move on. Once sorted, the bananas are boxed and prepped for shipping. They might travel by truck to a port, then across the ocean in temperature-controlled containers, and finally to distribution hubs that feed into the main processing factory. The bananas are kept at around the mid-50s degrees Fahrenheit to slow ripening, each carrying pallets of bananas ready for inspection. At this food processing factory, everything else goes straight to a washing station. Then comes the peeling. Depending on the scale, peeling is either done by hand, with workers standing side by side, or by specialized machines that can peel thousands of bananas an hour. Up next is the slicing process. Instead, they use high-speed slicing machines, each banana turning into uniform discs in a matter of seconds. The thickness can be adjusted. Thinner slices typically fry faster and get super crispy. As these slices fall onto a conveyor belt, if a slice is bruised or off-color, a short burst of air kicks it out of the line. Frying. Banana chips are fried in hot oil, often coconut or palm oil, at around 350 to 375 degrees Fahrenheit. The slices float along a conveyor submerged in oil for a few minutes, losing moisture as they soak up the heat. This transforms them into that golden brown chip we all know. Right after cooking, the chips move to a seasoning station. This could be a rotating drum where a specific flavor, salt, sugar, cinnamon, chili, gets dusted onto each batch. Big sprayers or tumblers coat the chips evenly, ensuring that every handful delivers a consistent taste. Any reputable food processing factory devotes serious effort to quality control. A quick lab check might measure moisture content to ensure longevity on store shelves. If it's too high, chips can go stale or mold quickly. At high speed, banana chips are weighed, portioned, and funneled into bags or plastic tubs. Heat sealers clamp them shut to lock in freshness, and a label machine adds branding, nutrition info, and a best buy date. Large-scale factories might churn out thousands of sealed units per hour. These are then boxed, stacked on pallets, and moved to distribution centers. For bigger brands, packaging often features vibrant designs to grab consumer attention. You might see phrases like "tropical delight." Once packaged, banana chips travel to warehouses across the country. Retailers place orders based on demand forecasts, ensuring shelves stay stocked. You'll see them in mainstream grocery stores, organic markets, and online retailers. From tropical farms where massive hands of bananas are chopped and cleaned, to a bustling food processing factory filled with conveyor belts, advanced slicers, and high-temperature fryers, banana chips undergo a transformation worthy of the amazing food processing title. If you've made it this far, hit that like button, comment below with your favorite flavor of banana chips, and subscribe for more deep dives into food factory operations.
Hello there, all you connoisseurs of everyday marvels. Welcome to Process Z, the channel where we dive elbow deep into the story behind some of the most intriguing items on our planet. Today, we're zeroing in on something that's literally older than humanity itself, yet it still makes a cameo on our dinner tables every single night: Himalayan salt. Yeah, that pink rock you've seen in fancy grinders and those luminous salt lamps. It's time to see how it goes from ancient subterranean treasure to the sprinkle on your mac and cheese. Get comfy, grab a snack, maybe something that needs salting, and let's unravel every stage of this journey. Oh, and before we jump down the salt mine, do me a favor. Go ahead and tap that subscribe button for Process Z. A quick click from you helps us keep exploring the coolest processes on the planet. Ready? Let's dig in. Our journey kicks off in the famed salt ranges of Pakistan, often cited as part of the broader Himalayan region. Picture a massive network of tunnels and caverns, where neon white headlights reveal rosy-hued salt walls. This is the Kevra salt mine, one of the largest sources for Himalayan salt. Modern technology has replaced old-school pickaxes with drilling rigs and advanced cutting machines. Safety is absolutely crucial. Geologists and mining engineers must confirm stability to protect workers and preserve the mine's structural integrity. They'll often leave hefty pillars of salt in place to support the ceiling, like an ancient cathedral built by nature itself. Once a workable section is deemed secure, the machines get to work. Process Z Pro Tip: if you ever see pictures or videos of these mining machines in action, it's not just a dusty cave. It's a full-fledged operation with powerful lights, conveyor belts, and specialized drilling gear. The vibrations echo through the chambers as chunks of salt peel off like layers of rock candy, though I wouldn't suggest eating it straight from the wall, no matter how tempting. Different mines favor different approaches, but typically, Himalayan salt is loosened with either mechanical cutters or carefully placed explosives. Mechanical cutters grind away at the salt surfaces, releasing big pink shards that tumble onto conveyor belts. In certain zones, controlled blasts are used to break off entire salt slabs. It sounds wild, but these blasts are meticulously planned, like a choreographed dance between geology and engineering. The goal is to free as many large, high-quality salt chunks as possible while maintaining minimal debris. And yes, that pink hue, you see? It's due to iron oxide mingled with the sodium chloride. Mineral inclusions like magnesium or potassium may also add subtle color variations, almost like Earth's own avant-garde art exhibit under your feet. Once dislodged, the biggest salt rocks need to be hauled to ground level. Workers use heavy-duty loaders, trucks, or conveyor systems that carry the salt through the winding shafts. Stepping out into the sunlight with a mountain of salt glimmering in the back of a truck can be a surreal sight, a bit like watching pink gemstones in the daylight. Quality and size check. At the surface, there's a brief sorting phase. Some lumps might be too big. Some might contain too many impurities. Technicians make quick decisions about which pieces are prime for the next steps. Some monstrous salt boulders could weigh hundreds of pounds, so specialized machinery is used to maneuver them gently without snapping them into worthless gravel. After all, the whole point is to keep the raw material as pristine as possible. Now that we have giant slabs of salt, what's next? In many cases, a portion of the salt is processed near the mine itself. However, a substantial chunk of the Himalayan salt destined for the US market will take a long journey across oceans. Before it hops on that ship, it goes through initial cleansing and grading. Think of it as a pre-wash and inspection, making sure we don't ship a bunch of dirt and rock dust all the way across the planet. Once everything checks out, the salt is stacked in giant shipping containers and whisked off to port. At customs, officials verify the cargo's documentation, including country of origin labeling, which is vital for American import regulations. After that, the containers are loaded onto freight ships bound for the US weeks. Later, they arrive at ports, whether East Coast, West Coast, or Gulf region, where they're once again scrutinized by local agencies. At that point, the salt gets distributed to various food processing factories or specialized processing zones across the country, ready for the next stage in its transformation. Hey, it's your pal from Process Z, dropping in here with a quick request. If you're digging this behind-the-scenes look, make sure you click that subscribe button so we can keep bringing you more intriguing journeys. If you've got a fascination with any other product, be it coffee beans or sneaker manufacturing, comment below. Once Himalayan salt arrives at a US-based food processing plant, the real fun begins. Large mechanical arms or forklifts unload the slabs, which then go through comprehensive washing. Yes, I know, washing salt might sound contradictory, but this step is vital. Factory workers spray the salt with water to remove leftover debris, dust, or minor rock fragments. The water isn't used in copious amounts, just enough for a thorough rinse. They're cautious to ensure they don't dissolve all that pink gold they worked so hard to mine. Quality inspection. Next, lab technicians run tests, verifying there's nothing lurking in the salt that shouldn't be there, like heavy metals, contaminants, or random chunks of clay. The US Food and Drug Administration, FDA, has guidelines ensuring that any edible sold here meets specific thresholds for purity. If the salt passes muster, it's off to the grinding mills. Brace yourself for the pounding. In a typical food processing factory, the salt is fed into mechanical crushers or grinders. The chunky blocks get shattered into pieces ranging from large crystals to a granular powder, depending on the brand's end goal. Some producers want large, coarse crystals that look awesome on a steak or in a see-through grinder. Others require a more refined, pun-intended powder-like texture to match the consistency of table salt. Dust control is a key factor during this stage. An entire cloud of salt can form if the system isn't sealed properly. That's where vacuum ducts and enclosed conveyors come in. No one wants workers hacking up salt dust all day. It's a careful dance. Keep the equipment ventilated while preventing fine particles from spreading all over the facility. Now, you might assume all Himalayan salt is the same, but there's an entire subculture of specialty salts out there. Some factories run an extra process where they blend the salt with herbs, spices, or even smoked flavoring. Ever see smoked Himalayan salt or herb-infused pink salt on store shelves? That's done by carefully mixing flavor concentrates or dried herbs during the final blending stage. The salt is tumbled and rotated until the flavors coat every crystal. In addition, certain brands add anti-caking agents like calcium silicate to keep salt from forming lumps, especially in humid areas. Others advertise a pure approach, no extras whatsoever, just raw pink crystals. Purists argue it's the only way to truly experience Himalayan salt. But hey, whichever you choose, you still end up with something that'll make your dishes pop. The packaging line is a marvel of modern automation. Picture big hoppers dropping pre-measured amounts of salt into jars, bags, or pouches. A conveyor belt glides them along to a sealing station, where plastic lids are snapped on or heat seals are applied. For bigger bulk orders, large sacks are filled and fastened, often bound for restaurants or wholesale markets. Labeling is more critical than you'd think. Packages in the US have to show net weight, potential additives, like anti-caking agents, and disclaimers about the origin. You'll often see something like, product of Pakistan, or mined from the Himalayan region. In fancy gourmet stores, some packaging even highlights the specific mine or region it came from. One final note on packaging. Some companies put a window on the bag so you can see the pink crystals inside. Others color code the packaging for coarse, fine, or rock salt. There's more marketing flair than you might expect for something as basic as salt. Before Himalayan salt heads to retailers, each batch passes another round of checks. Workers and automated scanners look for broken seals, misprinted labels, or even color inconsistencies. A sample from each lot may go back to the in-house lab for final testing. They confirm it meets moisture standards and doesn't have weird contaminants. Considering the rigors of US import and food safety laws, it's thorough, if not a bit tedious. When everything is signed off, the finished packages go into warehouse storage, typically in a climate-controlled environment. While salt itself is stable and doesn't spoil, controlling moisture levels in the facility prevents lumps or caked salt from forming. After all, the last thing you want is a soggy block. Salt can't stay in the factory forever. Once it's packed and ready, it's shipped off to distribution centers or directly to retail chains. You'll find Himalayan salt in big box grocery stores, local co-ops, organic shops, and of course that large online marketplace we all love. It's right there next to regular table salt, kosher salt, and sea salt, waiting to join your spice cabinet. Large retailers might specify their own packaging or labeling details. Others might just reorder from existing brands. For the consumer, it's a simple grab off the shelf. But behind the scenes, a global supply chain has hustled to bring that pink stuff to your dinner plate. By the time you twist that grinder or pour out a tablespoon from a bag, you're enjoying the fruit of an extensive labor chain. Mining machines, factory processes, shipping logistics, the whole 9 yards. That pinch of pink might even be older than the dinosaurs that once roamed Earth. By the way, if you're loving this deep dive into the labyrinth of food processing machinery, now's your second gentle reminder. Subscribe to Process Z and throw a comment our way. Let us know if you prefer coarse or fine Himalayan salt. We read every comment seriously. It's not just about the kitchen. Himalayan salt has carved out a niche in wellness culture across the US. Whether it's decorative salt lamps that glow softly in bedrooms or spa treatments touting respiratory health benefits, Himalayan salt manages to infiltrate more corners of life than you'd imagine. While scientific evidence can be mixed, plenty of Americans enjoy the ambiance a pink salt lamp creates. Ever walk into a yoga studio or spa with a gentle pinkish-orange glow in the corner? Yep, that's likely Himalayan salt. It's a testament to how versatile and marketable this stuff has become. And just like that, we've traced Himalayan salt's entire trajectory. mined from ancient sea deposits, hauled through winding tunnels, shipped to US factories, cleansed, crushed, packaged, and placed on store shelves. From your steak marinade to the soothing glow by your bedside, it's an unsung hero with a truly legendary backstory. So, what's the takeaway? First, next time you sprinkle pink salt on your fries, remember the epic geological saga behind those grains. Second, when a friend brags about their new salt lamp or fancy finishing salt, you can wow them with the real scoop, how each crystal made a globe-trotting journey before ever hitting your plate.
Have you ever stepped into a Dunkin' Donuts shop and been greeted by the sweet aroma of freshly fried dough? Every single day, millions of donuts are produced to meet America's insatiable craving for these treats. But how exactly do factories churn out such massive quantities while ensuring each donut tastes just right? In this video, we're unveiling the donut factory process, from mixing the dough to adding those irresistible glazes and toppings. By the end, you'll appreciate the intricate planning, teamwork, and technology that turn humble ingredients into the iconic Dunkin' Donuts millions enjoy. Dunkin' Donuts began in 1950 when William Rosenberg opened his first shop in Quincy, Massachusetts, offering fresh coffee and donuts. From those modest beginnings, the brand skyrocketed into an international success, credited with popularizing quick, convenient access to coffee and pastries. Despite its enormous reach, the heart of its operation still revolves around making top-quality donuts. Though many stores produce or finish donuts on-site, the core dough and large batches often originate in specialized American factories equipped to handle mass production. This blend of tradition and innovation underpins the brand's enduring popularity. Picture a sprawling industrial space humming with machinery. That's a typical donut factory supplying Dunkin' Donuts. Each facility is divided into zones: storage and quality control, warehouses that keep flour, sugar, yeast, and other ingredients at precise conditions. Mixing and dough prep. Rows of industrial mixers combine huge quantities of ingredients continuously. Cutting and proofing. Automated stations shape donuts and give them time to rise in controlled environments. Frying, glazing, and packaging. Conveyor belts lead donuts through hot oil, drenching them in glaze or frosting, then swiftly packaging them for delivery. By organizing each step in a linear flow, factories reduce delays, maintain consistent quality, and swiftly scale up production. To maintain that signature Dunkin' Donuts flavor, consistency in ingredients is crucial. Factories store bulk quantities of refined flour, sugar, salt, and yeast, making sure each meets strict quality standards. Temperature, humidity, and sanitation are rigorously monitored. Any deviation in flour moisture or yeast potency can alter the donut's taste and texture. Frequent inspections and lab tests confirm that every shipment of raw materials remains uniform. This unwavering commitment to ingredient quality allows donut lovers to enjoy the same great taste wherever they go. The dough-making stage is the lifeblood of any donut factory process. Massive mixers combine flour, sugar, yeast, water, and fats in batches that can weigh hundreds of pounds. Technicians adjust mixer speeds and temperatures to achieve the ideal elasticity. Overmixing risks a tough donut, while undermixing may lead to inconsistent rising. In these industrial setups, sensors track dough temperature, moisture, and consistency to ensure the perfect base. A slight tweak in mixing time can make a world of difference in the final product's taste and fluffiness. Many factories incorporate a kneading phase, either in the same mixer or a specialized machine, to strengthen the dough. This process develops gluten, giving donuts that airy, melt-in-your-mouth texture. Operators check dough samples throughout the kneading cycle, looking for an elastic, smooth quality. If the dough overheats or the yeast activates prematurely, it can disrupt proofing and lead to dense, uneven donuts. By carefully fine-tuning kneading times, factory staff help ensure each donut has the characteristic Dunkin' Donuts consistency. After kneading, the dough heads to machines that roll and cut it into rings or shapes. Mechanical cutters punch out thousands of donut forms per hour, each identical in thickness and diameter. Precision is key. Even a minor difference can throw off cooking times. Next comes proofing, where donuts rest in temperature and humidity-controlled chambers, allowing the yeast to ferment and the dough to rise. Automation here is carefully timed. Underproofed donuts come out dense, while overproofed ones can collapse in the fryer. Achieving that sweet spot of volume and lightness is a blend of engineering and baking expertise. Once proofed, the dough enters a long automated fryer, usually set around 365 degrees Fahrenheit, 185 degrees Celsius. Conveyor belts gently lower donuts into the hot oil, frying them on one side before flipping them over to ensure an even, golden crust. The time spent in the fryer must be precise. Too long, and the donuts turn greasy. Too short, and they're undercooked. Factory staff keep close tabs on oil quality, temperature, and cooking duration. In high-volume facilities, this stage runs continuously, producing thousands of perfectly fried donuts per hour. Emerging from the fryer, donuts ride along cooling conveyors until it's time for glazing or icing. Classic glaze is a simple mix of sugar, water, and flavoring. For more decadent varieties, thicker frostings or icings are applied. Specialty donuts may receive sprinkles, candy pieces, or even cookie crumbles. Some factories use advanced machinery to drizzle patterns or control exact topping placement. Despite the automation, quality inspectors still check that each donut looks and tastes right. Any flaw can prompt quick adjustments to the glaze's consistency or the icing's temperature. The result? A balanced coating that complements the donut's fluffy interior. After glazing, donuts travel further along conveyors to let the toppings set. The sugar glaze hardens just enough to form a protective shell, locking in freshness. By the time donuts reach the end of the line, they have cooled sufficiently for packaging. Technicians regularly taste test donuts at this stage, ensuring the flavor, texture, and sweetness align with Dunkin' Donuts standards. Adjustments, like raising the ambient temperature to help icing adhere, can be made on the fly to maintain uniform quality. With such high output, food safety is paramount. Factories implement hazard analysis and critical control points, HACCP, to identify contamination risks at every stage: storage, mixing, frying, and finishing. Equipment undergoes scheduled cleanings and staff follow stringent hygiene protocols. Random sampling checks a donut's weight, flavor, internal structure, and pH levels. Any issue detected triggers an immediate response, from recalibrating machines to discarding a problematic batch. These measures guarantee that every donut is safe, consistent, and up to brand standards. Packaging depends on where donuts are headed. Some are shipped in large trays directly to Dunkin' Donuts stores for finishing touches, while others are fully packaged for retail or events. Automated arms often place donuts into boxes or onto racks, which are sealed and labeled for tracking. Detailed labeling includes production times, expiration dates, and flavor varieties, helping managers across the supply chain monitor freshness. This stage also sets up the donuts for efficient loading onto trucks, ensuring they remain intact and appetizing during transit. Dunkin' Donuts relies on extensive distribution networks to keep its stores stocked, sometimes multiple times a day during peak demand. Large trucks equipped with temperature controls transport donuts from regional factories to nearby stores. Routes are planned to minimize travel time and preserve product quality. Many factories run around the clock, shipping out donuts to match breakfast rushes, midday snackers, and late-night cravings. Coordinating logistics, especially during seasonal surges or holiday promotions, requires meticulous scheduling, with factory managers adjusting output to meet rising demand for everything from classic glazed donuts to special themed varieties. It's hard to fathom just how many donuts come out of a single factory. Some facilities crank out tens of thousands of donuts per hour, easily hitting the millions mark in a week. This colossal volume demands ultra-efficient systems for dough preparation, frying, and finishing. Staff members monitor multiple conveyor lines, and computerized tracking systems quickly identify bottlenecks. Although Dunkin' Donuts is known for classic glazed and Boston cream, innovation is constant. Large production plants have test kitchens exploring new fillings, frostings, and dough formulas. Seasonal specialties, like pumpkin spice or heart-shaped donuts, roll out after careful testing to ensure they fit factory capabilities. Machines can be recalibrated for different shapes, sizes, or toppings without disrupting the main production flow, allowing for seamless innovation. This adaptability helps Dunkin' Donuts stay fresh and relevant, appealing to both traditionalists and those chasing the latest flavor trend. In an era of eco-consciousness, large donut factories strive to reduce energy use, manage waste, and minimize packaging. Some plants recapture heat from frying or reuse fryer oil for other industrial applications. Others optimize cutting processes to reduce dough scraps. Packaging is being redesigned for recyclability, and distribution routes are being streamlined to cut emissions. While these efforts vary by location, they reflect a growing industry trend to balance high-volume output with environmental responsibility, a challenge Dunkin' Donuts and similar brands are increasingly taking on. Despite sophisticated machines, human expertise keeps everything running smoothly. Skilled operators tweak dough consistency, fix sudden mechanical glitches, and uphold safety standards. Maintenance teams quickly resolve conveyor jams or fryer malfunctions, ensuring minimal production delays. Quality assurance specialists taste test random batches, always comparing results against Dunkin' Donuts benchmarks. Working in shifts, employees often develop a sense of camaraderie, knowing their collective effort satisfies sweet cravings nationwide. Ultimately, these teams are the unsung heroes behind every soft, sweet bite. Rapid production. Some lines can produce a glazed donut in under 20 minutes, from dough mixing to icing. Robot decorators. Advanced factories feature robotic arms that precisely drizzle icing or sprinkle toppings. Overnight. Operations. Many facilities ramp up production late at night so stores have fresh donuts by dawn. Experimental flavors. Labs have tested savory, spicy, and exotic donut recipes, though only a fraction make it to market. All-day popularity. While donuts are a breakfast staple, many customers buy them well past noon, which keeps production schedules flexible. Dunkin' Donuts has gone international, adapting flavors to suit local palates, like matcha donuts in Asia or dulce de leche in Latin America. However, much of the technical knowledge behind mass production originates from its US factories, which set standards for consistency and quality. Even with local twists, the overall emphasis on streamlined, large-scale operations remains the same. The success of these American facilities has influenced donut production methods worldwide, showing that clever engineering can deliver tasty treats on a grand scale. The next time you bite into a Dunkin' Donut, remember it's not just flour, sugar, and oil. It's the product of a vast, carefully orchestrated system. From industrial mixers to blazing fryers and intricate topping stations, every donut involves a series of well-honed steps. Meanwhile, a dedicated workforce ensures safety, flavor, and variety day in and day out. Dunkin' Donuts serves as a prime example of how traditional baking blends with modern engineering to satisfy millions of sweet tooths.
Ever wonder how the drink that fuels athletes, gamers, and CEOs alike is made? Red Bull isn't just an energy drink. It's the fuel behind epic moments, wild adventures, and global success stories. But what really goes into every can? Known for its ability to boost energy, increase alertness, and fuel both mental and physical performance, Red Bull has become a staple beverage for athletes, students, and busy professionals alike. But have you ever wondered what goes into producing millions of cans of this iconic drink every day? In this video, we'll take a deep dive into how Red Bull is made in mega factories around the world, unveiling every step from sourcing the ingredients to sealing the final product. The story of Red Bull began in the bustling streets of Bangkok, Thailand in 1982. A local drink called Krating Daeng, created by Chaleo Yuvidya, was popular among Thai laborers needing an energy boost. Austrian entrepreneur Dietrich Mateschitz discovered the drink during his travels and saw its global potential. Mateschitz didn't just introduce Krating Daeng to the Western market, he reimagined it. With Chaleo's partnership, they launched Red Bull in Austria in 1987, marking the start of what would become one of the most successful beverages in the world. Today, Red Bull dominates the global energy drink market, thanks to clever branding and innovation. When Red Bull first launched in Europe, it wasn't just a new drink, it was an entirely new concept. Energy drinks were rare in the Western market, and Mateschitz knew that merely offering the product wouldn't be enough. The original Krating Daeng was adjusted to better suit European palates, making it slightly less sweet and more refreshing. What really set Red Bull apart, however, was its association with adventure and extreme sports. The slogan, "Red Bull gives you wings," became a cultural phenomenon, aligning the brand with daring athletes and exciting events, from Formula One to cliff diving competitions. Red Bull's recipe relies on a carefully selected combination of ingredients, each serving a specific function. The most notable ones include caffeine, taurine, glucose, sucrose, and B group vitamins. Caffeine helps improve alertness, taurine supports neurological function, and the sugars provide an instant energy source. These ingredients are sourced from different regions around the world to ensure top-tier quality. Whether it's glucose from Europe or caffeine extracts from South America, the goal is to maintain the highest standards for every batch. There's a persistent urban myth about the origin of taurine in Red Bull, that it's derived from bull semen. However, this couldn't be further from the truth. The taurine used in Red Bull is entirely synthetic and produced in laboratories under strict safety guidelines. This makes the drink not only safe, but also suitable for vegetarians and vegans. Taurine plays an essential role in maintaining proper hydration and supporting muscle function, which is why it's a crucial component in Red Bull's formula. Role of caffeine is a cornerstone ingredient in energy drinks, and Red Bull is no exception. A single 8.4 ounce can contain about 80 milligrams of caffeine, equivalent to a small cup of coffee. Caffeine stimulates the central nervous system, helping improve focus, reaction times, and endurance. This is why Red Bull is popular not only among athletes, but also among students and professionals seeking a quick mental boost. Red Bull is subject to rigorous safety checks and regulations. Organizations such as the European Food Safety Authority and the US Food and Drug Administration have confirmed that the ingredients in Red Bull are safe when consumed in moderation. The company also follows stringent manufacturing protocols to ensure every batch meets international safety and health standards. Once sourced, the raw ingredients are transported to Red Bull's factories. These facilities are equipped with advanced food processing technology to manage the ingredients efficiently. From glucose syrup to caffeine powder, each component arrives at the factory under strict temperature and storage conditions to maintain its quality. The production process begins with the precise mixing of ingredients. Automated systems measure and blend the components, ensuring the taste and functionality remain consistent across every batch. Slight variations in the formula could impact the product's taste or effectiveness, so precision is paramount. Sophisticated equipment is used to maintain the ideal ratio of ingredients, ensuring every can delivers the same energy boost. Production Red Bull cans are as iconic as the drink itself. These sleek, slim cans are made from high-grade aluminum sheets that are cut and molded into shape. A special coating is applied to the interior of the cans to prevent any chemical reaction between the beverage and the metal, ensuring the drink stays fresh and flavorful. The lightweight design not only makes the cans portable, but also supports the brand's sustainability goals. Filling and sealing automated machines handle the can filling process at lightning speed, filling thousands of cans every minute. Sensors monitor the exact amount of liquid poured into each can, ensuring uniformity. Once filled, the cans are immediately sealed to prevent contamination. This airtight seal is crucial for maintaining the drink's quality and freshness. After sealing, the cans undergo pasteurization. This process involves heating the cans to a specific temperature to kill any harmful bacteria or microorganisms that could compromise the product's safety. Pasteurization ensures that Red Bull can be shipped and stored without refrigeration, which is vital for global distribution. Red Bull's sleek, minimalist packaging is designed for convenience and portability. The slim cans fit easily into cup holders, pockets, and backpacks, making them perfect for people on the go. The design has become so iconic that it's instantly recognizable around the world. Red Bull's commitment to sustainability extends to its packaging. The cans are made from 100% recyclable aluminum, and recycling a single can saves enough energy to power a television for 3 hours. This eco-friendly approach aligns with the company's goal of reducing its environmental impact. Red Bull continuously explores ways to minimize its carbon footprint. Lightweight designs reduce the amount of aluminum used, while renewable energy sources power many of the company's factories. These initiatives are part of Red Bull's broader commitment to sustainable production practices. Producing millions of cans daily requires a robust manufacturing and logistics network. While Red Bull is actively working to reduce emissions, the sheer scale of its operations contributes to greenhouse gases. The company is committed to finding innovative ways to offset these emissions, including investing in carbon-neutral technologies. Red Bull's global success is built on its ability to deliver a consistent product. Every can undergoes rigorous quality checks to ensure it meets the company's high standards. This commitment to consistency ensures that consumers in New York, Tokyo, or Sydney enjoy the same Red Bull experience. Once the production process is complete, the cans are packed into boxes and prepared for shipment. Red Bull has an extensive distribution network that spans over 170 countries. Whether they're destined for a supermarket in Europe or a convenience store in Asia, the cans are carefully handled to ensure they arrive in perfect condition. And there you have it, an inside look at how Red Bull is made on a massive scale, combining cutting-edge technology with innovative production techniques. From sourcing the finest ingredients to ensuring consistent quality, every step reflects Red Bull's commitment to excellence. If you enjoyed this behind-the-scenes journey, don't forget to like this video. Drop a comment sharing your thoughts.
Cheese, a universal favorite, has been gracing tables across the globe for centuries. From the soft and creamy brie of France to the sharp and crumbly cheddar of England, cheese is a testament to culinary ingenuity. Historically, cheese was a local and artisanal craft, perfected by generations of cheesemakers. But as global demand for this dairy delight soared, the art of cheese production evolved. Today, massive factories combine time-honored traditions with cutting-edge technology to craft a stunning variety of cheeses. In this journey, we'll explore how these factories transform simple milk into an array of delectable cheeses loved by millions. Every great cheese starts with fresh milk sourced from trusted dairy farms. At the heart of the process is the milk's quality. It's not just an ingredient, it's the foundation. Delivered in massive tanker trucks, the milk arrives at the factory in quantities that can exceed thousands of gallons. Before any cheesemaking begins, the milk undergoes rigorous testing. Technicians check for purity, fat content, and pH levels, ensuring it meets the precise standards required for the cheese being produced. Whether it's cow's milk, goat's milk, sheep's milk, or even a blend, the careful selection of this vital ingredient sets the tone for the entire process. The journey from milk to cheese involves a series of delicate transformations. Depending on the type of cheese, the milk may need adjustments. For richer cheeses like cheddar, whole milk is used, while lighter cheeses like ricotta rely on skim milk. Skimming is achieved through centrifugation, a process where milk is spun at high speeds, causing the cream to rise to the top. The cream is skimmed off and repurposed for making butter, cream-based products, or ice cream. This step ensures that the milk is perfectly tailored for the cheese variety being crafted, maintaining balance and consistency in every batch. Once the milk is prepared, it moves on to pasteurization. This critical step involves heating the milk to high temperatures to eliminate harmful bacteria, ensuring safety without compromising the milk's natural flavors. While pasteurization is a legal requirement for many cheeses, it's also an essential quality control measure. Think of it as the milk's cleansing ritual, making it pure and ready for transformation into cheese. The process is done gently, preserving the milk's character while ensuring it's safe for consumption. With the milk pasteurized and ready, it's time to add the magic ingredient, starter cultures. These are specific strains of beneficial bacteria carefully chosen based on the type of cheese being made. The bacteria have a crucial job. They ferment the lactose in the milk, converting it into lactic acid. This process kickstarts the cheese's journey, developing its unique flavor profile and texture. For example, a starter culture used for Swiss cheese produces characteristic nutty notes, while the culture for brie creates its creamy consistency. These cultures are the unsung heroes, working silently yet powerfully to shape the cheese's personality. Next, we witness one of the most fascinating moments in cheesemaking, the curdling process. Enzymes like rennet are added to the milk. Rennet, which can be derived from both animal and microbial sources, causes the milk proteins to coagulate, separating the liquid whey from the solid curds. This is the first step where milk begins to take on its new form. The curds, rich in protein and fat, are the building blocks of cheese, while the whey, though separated, is far from wasted. It will find new life in other products. This transformation is a delicate dance of science and tradition, executed to perfection in modern factories. Once the curds have formed, they're cut into smaller pieces. The size of these cuts is not random. It directly influences the cheese's final texture. For instance, larger curds result in drier, firmer cheeses like cheddar, while smaller curds create softer varieties like mozzarella. Cutting the curds releases whey, which must be drained off to concentrate the curds further. This step requires precision and expertise, ensuring the curds are uniformly shaped and sized for optimal results in the next stages. Cooking the curds is where temperature plays a pivotal role. The curds are gently heated to a specific temperature, which helps expel more whey and allows the curds to firm up. The cooking process also affects the cheese's texture and flavor. For example, a higher cooking temperature yields firmer cheeses like Parmesan, while lower temperatures preserve the soft creaminess of brie. Every degree counts, and careful monitoring ensures the curds develop just the right consistency. With the whey largely removed, the curds are transferred into presses. This step is vital for shaping the cheese and eliminating any remaining moisture. The pressure applied depends on the type of cheese. Soft cheeses like feta require gentle pressing, while hard cheeses like Gouda need firm pressure to achieve their dense texture. The presses work uniformly, ensuring each cheese block is consistent in size, shape, and moisture content. The drained whey, rich in nutrients, is collected for further use in products like whey protein powders and nutritional supplements. Now comes the creative part, shaping the cheese. The pressed curds are placed into molds, which define the cheese's final form. These molds can range from simple rounds and blocks to intricate designs for specialty cheeses. Shaping isn't just about aesthetics. It influences the cheese's aging process by determining its surface area and exposure to air. Modern factories use automated systems to mold large quantities of cheese quickly and efficiently, ensuring uniformity across every batch. To enhance the flavor and preserve the cheese, it's immersed in a brine solution, a mixture of water and salt. This step not only gives the cheese its characteristic savory taste, but also helps form a natural rind, which protects it during aging. The brining time varies depending on the cheese type. Some are brined for hours, while others soak for days. The salt content absorbed by the cheese plays a critical role in defining its flavor profile, creating a perfect balance of taste and texture. Once brined, the cheese enters the maturation phase, where its true character emerges. In controlled environments with precise temperature and humidity, the cheese develops its unique flavors, textures, and aromas. Aging can last anywhere from a few weeks to several years, depending on the variety. During this time, microbial activity and enzymatic reactions create the complex taste profiles that make each cheese special. For example, a young Gouda is mild and creamy, while an aged Gouda offers sharp caramel-like notes. This stage is a testament to the patience and expertise of cheesemakers, as every day adds depth and nuance to the cheese. The duration of aging determines the cheese's flavor intensity. Younger cheeses are often mild and creamy, ideal for delicate dishes, while aged cheeses boast bold, complex flavors perfect for savory recipes. For example, Parmesan aged for over 2 years becomes a crumbly masterpiece, packed with umami and nutty notes. This flavor evolution is what makes cheese an endlessly versatile ingredient beloved by chefs and home cooks alike. With the cheese aged to perfection, it's ready for the world. Packaging is designed to protect the cheese during transportation, while showcasing its appeal on store shelves. Modern factories use automated systems to package large quantities quickly and hygienically. Labels provide essential information about the cheese's origin, aging process, and recommended uses. Once packaged, the cheese is distributed to grocery stores, specialty shops, and restaurants worldwide, ensuring it reaches consumers in peak condition. Let's not forget the whey, the often overlooked byproduct of cheesemaking. Rich in protein and nutrients, whey is far from waste. It's used to create protein powders, baked goods, and even bioplastics. This sustainable approach ensures that every part of the milk is utilized, reflecting the industry's commitment to innovation and efficiency. From the moment milk arrives at the factory to the final step of packaging, cheese production is a beautiful blend of tradition and technology. Each stage, meticulously executed, contributes to the creation of a product that's as diverse as it is delicious. So the next time you enjoy a slice of cheese, take a moment to appreciate the incredible journey that transformed humble milk into one of the world's most cherished culinary delights.
Imagine unearthing the secret behind the perfect blend of honey sweetness and zesty mustard that leaps from jars on supermarket shelves. What if we told you there's an industrial symphony behind your favorite condiment? In this exciting exploration, we reveal the hidden secrets of how honey mustard sauce is made in bulk. From the meticulous selection of premium ingredients to the dance of high-tech machinery and skilled artisans, each step is a captivating journey into flavor and science. This introduction not only satisfies our curiosity, but also promises an insider's view of the fascinating world where tradition meets cutting-edge technology to bring the beloved honey mustard sauce to life. The journey of making honey mustard sauce in bulk starts with selecting the finest ingredients. Factories ensure that honey, mustard seed, vinegar, spices, and other components meet strict quality standards. Sourcing quality ingredients is critical because the flavor of the final product depends heavily on the purity of these inputs. The use of organic honey and high-grade mustard powder, for instance, ensures a robust taste. Moreover, suppliers are often certified and follow sustainable practices, which contributes to the factory's reputation in producing safe, high-quality honey mustard sauce on a mass scale. Once the premium ingredients arrive at the manufacturing facility, they are stored in climate-controlled environments to preserve their freshness and prevent contamination. The factory follows rigorous food safety protocols and storage guidelines. For example, honey is kept in temperature-controlled tanks, while mustard seeds and spices are stored in dry, air-conditioned areas. By organizing ingredients in a controlled environment, the production line prevents spoilage and maintains the integrity of each component. This preparation stage is crucial because it sets the groundwork for a seamless production process when manufacturing honey mustard sauce in bulk. The next step in the production of the honey mustard sauce involves the blending of key ingredients. In large-scale manufacturing, automated mixing tanks combine honey, mustard, vinegar, water, salt, and selected spices. These industrial mixers are designed to ensure a homogeneous blend, achieving the desired consistency and flavor profile. The process often involves precise measurements, temperature control, and timing to replicate the same taste every time. This attention to detail is what guarantees the uniformity expected from factory-made honey mustard sauce, making sure that each batch matches the iconic flavor consumers love. Producing honey mustard sauce in bulk requires special mixing techniques to achieve the perfect emulsion. The bulk production process uses high-speed homogenizers to blend the ingredients thoroughly, ensuring that honey and mustard integrate seamlessly. These emulsification techniques prevent the separation of liquids and solid particles over time, ensuring a smooth texture. Factories often use continuous blending systems to produce large quantities of sauce efficiently, maintaining a consistent flavor profile. The use of such advanced equipment highlights the precision and care that goes into creating large batches of honey mustard sauce. As the sauce moves through the production line, rigorous testing is performed at various stages. Factories use pH meters, viscosity analyzers, and sensory panels to ensure that the product meets both flavor and safety standards. For instance, taste testers might sample the sauce to verify that the balance of sweetness and tanginess is just right, and lab tests check for microbial contamination. Continuous quality checks help maintain consistency across batches, making sure each jar of honey mustard sauce delivers the same high-quality experience. The sauce undergoes a cooling and stabilization phase. The bulk production facilities use cooling tunnels or spiral chillers to bring the temperature of the sauce down quickly. This rapid cooling prevents overcooking, which could alter the flavor and consistency. Stabilizers might be added to maintain the viscosity and prevent separation during storage. The cooling process is carefully monitored to ensure that the honey mustard sauce remains flavorful and visually appealing, maintaining the quality consumers expect when purchasing factory-made products. Once the honey mustard sauce has been blended, pasteurized, and cooled, it is ready for packaging. In large-scale factories, automated filling machines precisely dispense the sauce into bottles, jars, or pouches. These machines are calibrated to handle different container sizes and ensure minimal waste. The filling process is done in a sterile environment to prevent contamination. High-speed capping and sealing equipment then secure the containers, ensuring a tight seal that preserves freshness. Automation in filling not only speeds up production, but also maintains the consistency and hygiene standards required in producing honey mustard sauce in bulk. After filling, the containers of honey mustard sauce move along the packaging line. Packaging is a crucial part of the bulk manufacturing process because it affects both the shelf life of the product and its appeal to consumers. Labels are applied to each container, providing necessary product information such as ingredients, nutritional facts, and expiration dates. Many factories also incorporate branding elements into the labeling process, ensuring that their honey mustard sauce stands out on supermarket shelves. High-quality packaging materials are chosen to protect the sauce during transportation, and eco-friendly practices are often implemented to reduce environmental impact. The efficiency of a bulk production line is measured by its ability to produce high volumes of honey mustard sauce without compromising quality. These systems optimize the production process, reduce downtime, and increase output. By leveraging technology and automation, factories can produce thousands of liters of honey mustard sauce every day, meeting the demands of retailers and restaurants. This efficiency allows consumers to enjoy their favorite condiment while ensuring that the manufacturing process remains sustainable and cost-effective. Once packaged and labeled, the honey mustard sauce is ready to leave the factory. Distribution logistics play a key role in delivering the product from the factory to stores, restaurants, and consumers around the globe. Bulk production facilities often have dedicated logistics teams that coordinate shipping schedules, transportation methods, and inventory management. They work closely with distributors and retailers to ensure timely delivery while maintaining product integrity. Sustainability is increasingly important in industrial food production, and many honey mustard sauce factories are adopting eco-friendly practices. These may include sourcing honey from sustainable beekeeping operations, reducing water and energy usage during production, and recycling packaging materials. Factories might implement waste reduction strategies by reusing excess product or composting organic waste. By embracing green technologies and sustainable practices, manufacturers not only reduce their environmental footprint, but also appeal to eco-conscious consumers. The commitment to sustainability highlights how industrial manufacturing of honey mustard sauce can coexist with environmental responsibility. The production of honey mustard sauce in bulk has evolved with technological advances that improve efficiency, safety, and quality. Innovations such as the Internet of Things, IoT, allow real-time monitoring of production parameters, while artificial intelligence, AI, can predict maintenance needs, reducing downtime. Robotics and automation further enhance precision in mixing, filling, and packaging processes. These technological improvements ensure that factories can consistently produce high-quality honey mustard sauce while minimizing human error. As technology continues to progress, the methods used in bulk sauce manufacturing will become even more refined, offering new opportunities for flavor innovation and production efficiency. 15. Conclusion: the journey from raw ingredients to your table. The process of making honey mustard sauce in bulk is a fascinating blend of art and science. It involves careful ingredient sourcing, precise blending, rigorous quality control, and advanced technology. Each step in the factory is designed to ensure consistency, safety, and the beloved taste that consumers expect. By understanding how honey mustard sauce is made in bulk in factories, we gain insight into the complexities of industrial food production. This knowledge not only deepens our appreciation for the condiment, but also emphasizes the importance of quality, sustainability, and technological innovation in delivering a product that satisfies millions around the world.
Hey there! Have you ever pondered where a brightly colored gummy bear came from while holding it in your fingers? That little chewy treat is an intellectual, historical, and culinary marvel, not to mention a nibble. The modern industrial marvel that is gummy candy didn't begin as something that children and adults alike adore. It all started in the home of Hans Riegel, a confectioner from Germany. In the early 1920s, he started experimenting with a copper pot and a stove as his only tools. What was the outcome? The world of candies was forever changed when the gummy bear was born. The intriguing method of making gummy candy in modern factories is explored in this narration. Every stage of the manufacturing process, from ingredient selection to quality control, showcases the remarkable combination of human creativity and technical progress. Join me on this delicious adventure. Hans Riegel established Haribo in 1920 in Bonn, Germany. The story starts there. He created the first gummy bear in 1922, influenced by the European circus's famous dancing bears. These chewy sweets were first marketed in modest numbers, but swiftly became a worldwide phenomenon. The method and formula have changed over the years, incorporating new flavors, forms, and colors, as well as state-of-the-art technology. These days, you can get gummy sweets in every shape imaginable, from rings to worms and even vitamins. Gummy candy has changed over the years to mirror both technological development and shifting customer preferences. The components for gummy candy are hand-picked to guarantee uniformity in quality and flavor. A chewy texture is characteristic of gummy candy, and gelatin is the main ingredient responsible for this. Collagen is made from animal sources, specifically pig and cow bones and connective tissues. Because of its rigorous purification process, this gelatin has no flavor or smell, making it ideal for use in candy making. Gummy candy gets its distinctive melt-in-your-mouth quality from the thermoreversible gelatin, which melts when heated and hardens when cooled. The procurement of gelatin necessitates a meticulous supply chain. Processing facilities harvest and purify collagen from raw materials provided by farmers. To maintain sustainability and protect the well-being of the animals, these institutions adhere to stringent regulations. Manufacturers utilize a mix of sucrose, derived from sugarcane, and fructose from maize syrup to attain the ideal sweetness. These sugars do double duty by enhancing the candy's flavor and keeping it from drying out. Because it keeps the candy from crystallizing and keeps it smooth and malleable, corn syrup is highly prized. The production of sucrose begins in sugarcane plantations, which are often found in tropical regions. The sugarcane is first reduced to its raw sugar form after harvesting and then refined into a candy-making consistency. This sweet treat gets its taste from molasses, maple sugar, berries, and natural fruit extracts. The distinctive aromas of various gummy forms are created by enhancing these natural flavors with aromatic chemicals. There are natural and artificial sources for colors. Vibrant and uniform hues are guaranteed by regulated dyes such as red hash 40, yellow hash 5, and blue hash 1. Beetroot, turmeric, and spirulina natural colors are becoming more popular among health-conscious consumers. The candy's texture and shelf life are impacted by the pH balance, which is achieved by adding food-grade acids such as citric, malic, or tartaric acid. Sour gummy sweets get their tart flavor from these acids as well. For instance, citrus fruits are a common source of citric acid, which is then fermented and purified for commercial usage. The ideal formula for gummy candies is developed in collaboration between food technologists and chemists prior to manufacturing. The pros here play around with different quantities of ingredients until they find the sweet spot when flavor, texture, and presentation all come together. We make sure every recipe is up to par by testing it thoroughly for quality and safety. Science and art are both involved at this period. To guarantee a consistent quality and aesthetic appeal in the finished product, laboratories with cutting-edge equipment test the interactions of substances under different settings. There are a lot of moving parts on the road from raw ingredients to an ideal chewy gummy sweet. Here, we will dissect it. In large tanks designed for industrial use, the raw components are measured and blended to begin the compounding process. To maintain consistency, these tanks have state-of-the-art heating and cooling systems. At high heats, gelatin dissolves in water. Next, flavors, colors, and sweeteners are added one by one. To make a smooth candy base, stir often to avoid burning and to make sure it's heated evenly. To guarantee accurate measurements, human workers and automated systems work together. Before going on to the next step, sensors check the base's temperature and viscosity to make sure it passes all of the requirements. The next step is to mold the candy after the base is complete. As a molding medium, starch is utilized in this step by a specialized machine called the mogul. In addition to absorbing excess moisture and keeping the candy's shape while it cools, starch also prevents stickiness. Starch in trays. After leveling the surface, empty trays are filled with starch. To make the forms you want for your candies, all you need is a board that has molds on it to press into the starch. To fill the molds, a precise nozzle is used to pour the candy mixture into each cavity. Sweets that are both aesthetically pleasing and delicious can be made by the mogul using a combination of colors and tastes. The loaded trays are then transferred to a refrigeration chamber and left there for more than 24 hours. The candies get their signature texture and firmness from the lengthy cooling process. The candies are set at the ideal temperature and humidity during this period, so they don't get too sticky or hard. These circumstances are constantly being monitored by engineers who make adjustments as necessary. After the trays have cooled, they are turned upside down so the sweets can drop onto a vibrating sieve. The candies are cleaned and prepared for additional processing by using this sieve in conjunction with oscillating brushes to remove extra starch. To further increase their aesthetic value, gummy sweets may be subjected to other finishing processes after demolding. The sweets get their glossy, smooth appearance from a thin coating of wax or polishing agents. Because of its natural origins and glossy look, carnauba wax, made from the carnauba palm tree's leaves, is a popular choice. To enhance the texture and flavor of some gummy candies, they are coated with sugar or sourness. For sour gummies, this is a popular choice. Tumbling machines are used to apply these coatings in a uniform fashion. Before they are packaged, the completed sweets are separated and checked for quality. The packaging process is handled by automated machinery, which ensures efficiency and consistency. Packaged in airtight bags, boxes, or jars, these sweets are prepared to be distributed to retailers all around the globe. The function of packaging extends beyond mere containment. It serves as a means of branding as well. Products are attractive and convenient for consumers because to their vibrant appearance and resealable characteristics. Making sure the gummy candy is of high quality is an important step in the process. To guarantee it satisfies specified criteria, every batch is tested extensively. Lab testing verify the chemical qualities, including pH and moisture content, while sensory panels assess the sweet's look, texture, and flavor. The raw materials are the first point of quality control. In order to guarantee a steady supply of premium ingredients, all suppliers are thoroughly reviewed. To guarantee the product meets expectations, random samples are taken at each step, from mixing to final packing. The production of gummy sweets exceeds 160 million per day on a global scale. Gummy bears and worms are the two most beloved shapes of gummy candies. More complex confectionery shapes are being considered using cutting-edge technologies such as 3D printing. For those who are looking for a nutritious snack, there are gummy sweets that have been enhanced with vitamins. There are a lot of moving parts in making gummy candies. Butter, a simple yet indispensable part of American kitchens. Whether it's slathered on toast, melted over popcorn, or whipped into baked goods, this golden block of joy brings flavor, richness, and comfort to our daily lives. But have you ever wondered how this magical ingredient goes from a cow to your plate? The story of butter is as rich as its taste, tracing back thousands of years when it was accidentally created in animal skin pouches. Fast forward to today, butter is a symbol of culinary indulgence, produced on a massive scale with modern technology. Let's embark on this fascinating journey, uncovering the farm-to-factory secrets behind butter. Butter's roots run deep, originating over 4,000 years ago in ancient Mesopotamia. Initially churned by hand, it was a luxury item reserved for rituals and the wealthy. Over time, butter became a staple across cultures, symbolizing prosperity and sustenance. In America, the Industrial Revolution transformed butter making from a home craft to a large-scale industry. The introduction of cream separators and mechanical churns allowed factories to produce butter faster and more efficiently, meeting the growing demands of a butter-loving nation. Today, butter is a $2 billion industry in the United States, consumed in everything from home cooking to high-end culinary creations. But its journey from farm to factory remains a marvel of precision, care, and science. The story of butter begins on dairy farms, where the stars of the show, dairy cows, graze on nutrient-rich grass and feed. In the United States, breeds like Holstein and Jersey are prized for their milk, known for its high butterfat content. The role of dairy farmers. Farmers play a crucial role in ensuring cows are healthy and stress-free. Advanced nutrition plans, regular health checkups, and spacious barns contribute to the quality of milk produced. Seasons and yield. Milk production peaks in cooler months, but thanks to advancements in farming, consistent yields are maintained year-round. Milking process. Using state-of-the-art milking machines, farmers extract milk in a hygienic and efficient manner. The milk flows into refrigerated storage tanks, preserving its freshness until it's time for transportation. Once collected, the milk begins its journey to the factory. Specially designed tanker trucks transport milk at a cool 39 degrees Fahrenheit, 4 degrees Celsius, to prevent spoilage. These trucks are equipped with insulated compartments to maintain the milk's temperature, even during long hauls. At the factory gates, the milk undergoes initial quality checks, including tests for freshness, fat content, and any signs of contamination. Only the best milk makes it to the butter-making process. At the factory, the milk is poured into large stainless steel vats. Here, the magic begins. Testing and preparation. Each batch of milk is rigorously tested to ensure it meets quality standards. High-tech sensors check everything from its acidity to its fat content. Cream separation. Using a centrifugal separator, the milk is spun at high speeds to separate cream from skim milk. The cream, rich in butterfat, is funneled into separate tanks, while the skim milk is diverted for other uses like cheese or yogurt. Churning is the heart of butter making. This ancient technique has been perfected by modern machinery. Cream's journey. The separated cream is pasteurized, a process that heats it to kill harmful bacteria while preserving flavor. It's then cooled and sent to industrial churners. The churning process. Industrial churners spin the cream at high speeds, causing the fat molecules to clump together, forming butter granules. As these granules grow, they separate from the liquid, which we know as buttermilk. Transformation in action. This stage is mesmerizing. What starts as a silky liquid slowly solidifies into creamy, luscious butter. To improve texture and shelf life, the butter undergoes washing and kneading. Washing. Butter is washed multiple times with cold water to remove residual buttermilk. This step prevents spoilage and ensures a longer shelf life. Kneading. Machines. Knead the butter, smoothing its texture and eliminating air pockets. This is what gives butter its signature silky consistency. Butter's flavor profile depends on this crucial step: salted versus unsalted. For salted butter, fine grains of salt are mixed in evenly. Unsalted butter, on the other hand, is left pure, ideal for baking and recipes where precise flavor control is needed. Cultured butter. Some factories add bacterial cultures to the cream before churning, creating a tangy European-style butter that's increasingly popular in American kitchens. Now that the butter is ready, it's time to package it for consumers. Shaping. Butter is molded into various shapes, sticks, blocks, or tubs, depending on the product type. Packaging. The butter is wrapped in protective materials like aluminum foil or parchment paper, designed to block out light and air. These packages are then labeled with all the nutritional information and stamped with an expiration date. Efficiency. High-speed machines ensure thousands of butter sticks are packaged every hour, meeting the demands of grocery stores and food service businesses. Before butter reaches the market, it undergoes stringent quality checks. Texture and taste. Expert tasters evaluate the butter for consistency, flavor, and aroma. Advanced tech. Automated systems scan for imperfections, ensuring each stick of butter is flawless. Hygiene standards. Factories adhere to strict hygiene protocols, maintaining the highest standards in food safety. Once packaged, butter is stored in temperature-controlled warehouses before being shipped across the country. Logistics. Cold chain transportation ensures butter remains fresh during transit. Retail and beyond. Butter is distributed to grocery stores, restaurants, and bakeries, ensuring it's readily available wherever it's needed. The butter industry is constantly evolving to meet consumer demands and environmental challenges. Sustainability. Factories are adopting green practices, such as recycling water and using renewable energy. Flavored and plant-based butter. From garlic herb blends to vegan alternatives, innovation is driving new trends in butter production. Butter's journey from a dairy farm to your table is a testament to the fusion of tradition and technology. Every bite of butter carries the legacy of hard-working farmers, cutting-edge machinery, and a love for good food. Hey there! Have you ever pondered where a brightly colored gummy bear came from while holding it in your fingers? That little chewy treat is an intellectual, historical, and culinary marvel, not to mention a nibble. The modern industrial marvel that is gummy candy didn't begin as something that children and adults alike adore. It all started in the home of Hans Riegel, a confectioner from Germany. In the early 1920s, he started experimenting with a copper pot and a stove as his only tools. What was the outcome? The world of candies was forever changed when the gummy bear was born. The intriguing method of making gummy candy in modern factories is explored in this narration. Every stage of the manufacturing process, from ingredient selection to quality control, showcases the remarkable combination of human creativity and technical progress. Join me on this delicious adventure. Hans Riegel established Haribo in 1920 in Bonn, Germany. The story starts there. He created the first gummy bear in 1922, influenced by the European circus's famous dancing bears. These chewy sweets were first marketed in modest numbers, but swiftly became a worldwide phenomenon. The method and formula have changed over the years, incorporating new flavors, forms, and colors, as well as state-of-the-art technology. These days, you can get gummy sweets in every shape imaginable, from rings to worms and even vitamins. Gummy candy has changed over the years to mirror both technological development and shifting customer preferences. The components for gummy candy are hand-picked to guarantee uniformity in quality and flavor. A chewy texture is characteristic of gummy candy, and gelatin is the main ingredient responsible for this. Collagen is made from animal sources, specifically pig and cow bones and connective tissues. Because of its rigorous purification process, this gelatin has no flavor or smell, making it ideal for use in candy making. Gummy candy gets its distinctive melt-in-your-mouth quality from the thermoreversible gelatin, which melts when heated and hardens when cooled. The procurement of gelatin necessitates a meticulous supply chain. Processing facilities harvest and purify collagen from raw materials provided by farmers. To maintain sustainability and protect the well-being of the animals, these institutions adhere to stringent regulations. Manufacturers utilize a mix of sucrose, derived from sugarcane, and fructose from maize syrup to attain the ideal sweetness. These sugars do double duty by enhancing the candy's flavor and keeping it from drying out. Because it keeps the candy from crystallizing and keeps it smooth and malleable, corn syrup is highly prized. The production of sucrose begins in sugarcane plantations, which are often found in tropical regions. The sugarcane is first reduced to its raw sugar form after harvesting and then refined into a candy-making consistency. This sweet treat gets its taste from molasses, maple sugar, berries, and natural fruit extracts. The distinctive aromas of various gummy forms are created by enhancing these natural flavors with aromatic chemicals. There are natural and artificial sources for colors. Vibrant and uniform hues are guaranteed by regulated dyes such as red hash 40, yellow hash 5, and blue hash 1. Beetroot, turmeric, and spirulina natural colors are becoming more popular among health-conscious consumers. The candy's texture and shelf life are impacted by the pH balance, which is achieved by adding food-grade acids such as citric, malic, or tartaric acid. Sour gummy sweets get their tart flavor from these acids as well. For instance, citrus fruits are a common source of citric acid, which is then fermented and purified for commercial usage. The ideal formula for gummy candies is developed in collaboration between food technologists and chemists prior to manufacturing. The pros here play around with different quantities of ingredients until they find the sweet spot when flavor, texture, and presentation all come together. We make sure every recipe is up to par by testing it thoroughly for quality and safety. Science and art are both involved at this period. To guarantee a consistent quality and aesthetic appeal in the finished product, laboratories with cutting-edge equipment test the interactions of substances under different settings. There are a lot of moving parts on the road from raw ingredients to an ideal chewy gummy sweet. Here we will dissect it. In large tanks designed for industrial use, the raw components are measured and blended to begin the compounding process. To maintain consistency, these tanks have state-of-the-art heating and cooling systems. At high heats, gelatin dissolves in water. Next, flavors, colors, and sweeteners are added one by one. To make a smooth candy base, stir often to avoid burning and to make sure it's heated evenly. To guarantee accurate measurements, human workers and automated systems work together. Before going on to the next step, sensors check the base's temperature and viscosity to make sure it passes all of the requirements. The next step is to mold the candy after the base is complete. As a molding medium, starch is utilized in this step by a specialized machine called the mogul. In addition to absorbing excess moisture and keeping the candy's shape while it cools, starch also prevents stickiness. Starch in trays. After leveling the surface, empty trays are filled with starch. To make the forms you want for your candies, all you need is a board that has molds on it to press into the starch. To fill the molds, a precise nozzle is used to pour the candy mixture into each cavity. Sweets that are both aesthetically pleasing and delicious can be made by the mogul using a combination of colors and tastes. The loaded trays are then transferred to a refrigeration chamber and left there for more than 24 hours. The candies get their signature texture and firmness from the lengthy cooling process. The candies are set at the ideal temperature and humidity during this period, so they don't get too sticky or hard. These circumstances are constantly being monitored by engineers who make adjustments as necessary. After the trays have cooled, they are turned upside down so the sweets can drop onto a vibrating sieve. The candies are cleaned and prepared for additional processing by using this sieve in conjunction with oscillating brushes to remove extra starch. To further increase their aesthetic value, gummy sweets may be subjected to other finishing processes after demolding. The sweets get their glossy, smooth appearance from a thin coating of wax or polishing agents. Because of its natural origins and glossy look, carnauba wax, made from the carnauba palm tree's leaves, is a popular choice. To enhance the texture and flavor of some gummy candies, they are coated with sugar or sourness. For sour gummies, this is a popular choice. Tumbling machines are used to apply these coatings in a uniform fashion. Before they are packaged, the completed sweets are separated and checked for quality. The packaging process is handled by automated machinery, which ensures efficiency and consistency. Packaged in airtight bags, boxes, or jars, these sweets are prepared to be distributed to retailers all around the globe. The function of packaging extends beyond mere containment. It serves as a means of branding as well. Products are attractive and convenient for consumers because to their vibrant appearance and resealable characteristics. Making sure the gummy candy is of high quality is an important step in the process. To guarantee it satisfies specified criteria, every batch is tested extensively. Lab testing verify the chemical qualities, including pH and moisture content, while sensory panels assess the sweet's look, texture, and flavor. The raw materials are the first point of quality control. In order to guarantee a steady supply of premium ingredients, all suppliers are thoroughly reviewed. To guarantee the product meets expectations, random samples are taken at each step, from mixing to final packing. The production of gummy sweets exceeds 160 million per day on a global scale. Gummy bears and worms are the two most beloved shapes of gummy candies. More complex confectionery shapes are being considered using cutting-edge technologies such as 3D printing. For those who are looking for a nutritious snack, there are gummy sweets that have been enhanced with vitamins. There are a lot of moving parts in making gummy candies. Butter, a simple yet indispensable part of American kitchens. Whether it's slathered on toast, melted over popcorn, or whipped into baked goods, this golden block of joy brings flavor, richness, and comfort to our daily lives. But have you ever wondered how this magical ingredient goes from a cow to your plate? The story of butter is as rich as its taste, tracing back thousands of years when it was accidentally created in animal skin pouches. Fast forward to today, butter is a symbol of culinary indulgence, produced on a massive scale with modern technology. Let's embark on this fascinating journey, uncovering the farm-to-factory secrets behind butter. Butter's roots run deep, originating over 4,000 years ago in ancient Mesopotamia. Initially churned by hand, it was a luxury item reserved for rituals and the wealthy. Over time, butter became a staple across cultures, symbolizing prosperity and sustenance. In America, the Industrial Revolution transformed butter making from a home craft to a large-scale industry. The introduction of cream separators and mechanical churns allowed factories to produce butter faster and more efficiently, meeting the growing demands of a butter-loving nation. Today, butter is a $2 billion industry in the United States, consumed in everything from home cooking to high-end culinary creations. But its journey from farm to factory remains a marvel of precision, care, and science. The story of butter begins on dairy farms, where the stars of the show, dairy cows, graze on nutrient-rich grass and feed. In the United States, breeds like Holstein and Jersey are prized for their milk, known for its high butterfat content. The role of dairy farmers. Farmers play a crucial role in ensuring cows are healthy and stress-free. Advanced nutrition plans, regular health checkups, and spacious barns contribute to the quality of milk produced. Seasons and yield. Milk production peaks in cooler months, but thanks to advancements in farming, consistent yields are maintained year-round. Milking process. Using state-of-the-art milking machines, farmers extract milk in a hygienic and efficient manner. The milk flows into refrigerated storage tanks, preserving its freshness until it's time for transportation. Once collected, the milk begins its journey to the factory. Specially designed tanker trucks transport milk at a cool 39 degrees Fahrenheit, 4 degrees Celsius, to prevent spoilage. These trucks are equipped with insulated compartments to maintain the milk's temperature, even during long hauls. At the factory gates, the milk undergoes initial quality checks, including tests for freshness, fat content, and any signs of contamination. Only the best milk makes it to the butter-making process. At the factory, the milk is poured into large stainless steel vats. Here, the magic begins. Testing and preparation. Each batch of milk is rigorously tested to ensure it meets quality standards. High-tech sensors check everything from its acidity to its fat content. Cream separation. Using a centrifugal separator, the milk is spun at high speeds to separate cream from skim milk. The cream, rich in butterfat, is funneled into separate tanks, while the skim milk is diverted for other uses like cheese or yogurt. Churning is the heart of butter making. This ancient technique has been perfected by modern machinery. Cream's journey. The separated cream is pasteurized, a process that heats it to kill harmful bacteria while preserving flavor. It's then cooled and sent to industrial churners. The churning process. Industrial churners spin the cream at high speeds, causing the fat molecules to clump together, forming butter granules. As these granules grow, they separate from the liquid, which we know as buttermilk. Transformation in action. This stage is mesmerizing. What starts as a silky liquid slowly solidifies into creamy, luscious butter. To improve texture and shelf life, the butter undergoes washing and kneading. Washing. Butter is washed multiple times with cold water to remove residual buttermilk. This step prevents spoilage and ensures a longer shelf life. Kneading. Machines. Knead the butter, smoothing its texture and eliminating air pockets. This is what gives butter its signature silky consistency. Butter's flavor profile depends on this crucial step. Salted versus Unsalted. For salted butter, fine grains of salt are mixed in evenly. Unsalted butter, on the other hand, is left pure, ideal for baking and recipes where precise flavor control is needed. Cultured butter. Some factories add bacterial cultures to the cream before churning, creating a tangy European-style butter that's increasingly popular in American kitchens. Now that the butter is ready, it's time to package it for consumers. Shaping. Butter is molded into various shapes, sticks, blocks, or tubs, depending on the product type. Packaging. The butter is wrapped in protective materials like aluminum foil or parchment paper, designed to block out light and air. These packages are then labeled with all the nutritional information and stamped with an expiration date. Efficiency. High-speed machines ensure thousands of butter sticks are packaged every hour, meeting the demands of grocery stores and food service businesses. Before butter reaches the market, it undergoes stringent quality checks. Texture and taste. Expert tasters evaluate the butter for consistency, flavor, and aroma. Advanced tech. Automated systems scan for imperfections, ensuring each stick of butter is flawless. Hygiene standards. Factories adhere to strict hygiene protocols, maintaining the highest standards in food safety. Once packaged, butter is stored in temperature-controlled warehouses before being shipped across the country. Logistics. Cold chain transportation ensures butter remains fresh during transit. Retail and beyond. Butter is distributed to grocery stores, restaurants, and bakeries, ensuring it's readily available wherever it's needed. The butter industry is constantly evolving to meet consumer demands and environmental challenges. Sustainability. Factories are adopting green practices, such as recycling water and using renewable energy. Flavored and plant-based butter. From garlic herb blends to vegan alternatives, innovation is driving new trends in butter production. Butter's journey from a dairy farm to your table is a testament to the fusion of tradition and technology. Every bite of butter carries the legacy of hard-working farmers, cutting-edge machinery, and a love for good food.
Have you ever wondered how KFC manages to produce millions of perfectly crispy and flavorful chicken nuggets every single day? Picture a masterfully orchestrated ballet of precision, speed, and innovation unfolding behind the scenes in sprawling American factories. Today, we're pulling back the curtain on one of the most beloved fast food favorites to reveal the captivating process of KFC's bulk chicken nugget production. Whether you're a dedicated foodie, eager to uncover the secrets behind your favorite bite, an aspiring restaurateur fascinated by large-scale food manufacturing, or simply intrigued by the intricate dance of ingredients and cutting-edge machinery, this video is your exclusive backstage pass. Join us as we embark on a journey from selecting the finest chicken to the state-of-the-art assembly lines that ensure every nugget is a perfect harmony of taste and consistency. Get ready to dive deep into the enthralling world where KFC chicken nuggets are brought to life. The foundation of these nuggets starts with sourcing high-quality chicken. KFC partners with trusted poultry suppliers across the United States to ensure that only the best chicken is used. These suppliers adhere to stringent quality and safety standards, providing chicken that is not only tender and flavorful, but also ethically raised. The commitment to quality begins at the very first step, guaranteeing that every nugget is made from premium ingredients that meet KFC's exacting specifications. Once the premium chicken arrives at the factory, the preparation process begins. The chicken is meticulously inspected and then deboned, ensuring that only the finest pieces are selected for nugget production. The meat is then ground to the perfect consistency, creating a smooth and uniform base for the nuggets. This preparation stage is crucial for maintaining the texture and flavor that KFC is renowned for, ensuring that each nugget delivers a consistent and delicious experience. Flavor is key to KFC chicken nuggets, and this is achieved through a meticulous seasoning and marinating process. The ground chicken is combined with a proprietary blend of herbs and spices carefully measured to maintain KFC's signature taste. This mixture is then allowed to marinate, allowing the flavors to penetrate deeply into the meat. The marinating process ensures that every bite of the nugget is bursting with the rich and savory flavors that fans love. After marinating, the seasoned chicken mixture is shaped into the iconic nugget form. Advanced machinery ensures that each nugget is uniformly shaped, providing consistency in size and appearance. This precision in shaping not only enhances the visual appeal, but also ensures even cooking, which is essential for achieving the perfect texture and flavor in every nugget. The next step in the production process is the breading and coating of the chicken nuggets. Each nugget is carefully dipped into a batter that forms a crispy outer layer. This batter is made from a blend of flour, spices, and other ingredients that create the distinctive KFC crunch. Following the batter, the nuggets are coated in a seasoned breading mixture, which adds an extra layer of flavor and texture. This double coating process is essential for delivering the satisfying crunch that KFC chicken nuggets are famous for. To achieve the perfect balance between a crispy exterior and a tender interior, the nuggets undergo a pre-frying stage. In this step, the breaded nuggets are partially cooked in hot oil, setting the coating and beginning the cooking process. This pre-frying ensures that the nuggets maintain their shape and texture during the final cooking phase, resulting in a consistently delicious product. After pre-frying, the chicken nuggets are quickly flash frozen to lock in freshness and preserve their quality. This rapid freezing process prevents the formation of large ice crystals, which can damage the texture of the meat. Flash freezing ensures that the nuggets retain their tenderness and flavor, ready to be cooked to perfection when they reach your local KFC restaurant. Quality control is a critical component of the KFC chicken nugget production process. Throughout each stage of manufacturing, rigorous inspections are conducted to ensure that every nugget meets KFC's high standards. From verifying the quality of the chicken to ensuring the consistency of the breading and seasoning, these quality checks guarantee that only the best nuggets make it to your plate. Once the nuggets pass all quality inspections, they're carefully packaged to maintain their freshness and integrity during transportation. KFC uses specialized packaging materials that protect the nuggets from moisture and temperature fluctuations, ensuring they arrive at restaurants in perfect condition. The packaging process is designed to be both efficient and secure, safeguarding the nuggets from production to delivery. Efficient logistics and supply chain management are essential for the seamless distribution of KFC chicken nuggets. KFC employs a sophisticated network of refrigerated transportation to keep the nuggets frozen and fresh as they travel from the manufacturing facilities to restaurants across the country. Real-time tracking systems monitor the movement of shipments, ensuring timely deliveries and minimizing the risk of delays or disruptions. At KFC restaurants, the final cooking of chicken nuggets is performed using advanced kitchen equipment designed to ensure consistency and quality. High-precision fryers maintain optimal temperatures, allowing nuggets to cook evenly and achieve the perfect golden brown color. This technology not only enhances the flavor and texture of the nuggets, but also ensures that each batch is cooked to the exact specifications that KFC customers expect. Behind every batch of KFC chicken nuggets is a team of skilled and dedicated employees. KFC places a strong emphasis on workforce training, ensuring that all staff members are proficient in the cooking and handling processes. Comprehensive training programs cover everything from food safety protocols to efficient cooking techniques, empowering employees to deliver high-quality nuggets consistently. KFC is committed to sustainability and ethical practices throughout its chicken nugget production. This includes sourcing chicken from suppliers that adhere to humane farming practices and implementing environmentally friendly manufacturing processes. By prioritizing sustainability, KFC ensures that its chicken nuggets are not only delicious but also responsibly produced, aligning with global efforts to promote environmental stewardship. Innovation plays a key role in the continuous improvement of KFC chicken nuggets. KFC explores new ingredient sourcing methods to enhance the quality and flavor of its nuggets. This includes experimenting with different seasoning blends, exploring alternative protein sources, and incorporating natural ingredients that appeal to health-conscious consumers. By staying at the forefront of ingredient innovation, KFC ensures that its chicken nuggets remain a favorite among customers. While KFC chicken nuggets are a beloved indulgence, KFC also prioritizes health and nutrition. The production process incorporates measures to reduce fat and calorie content without compromising on taste or texture. Additionally, KFC provides transparent nutritional information, allowing customers to make informed choices about their meals. Balancing flavor with nutritional value is a key aspect of KFC's approach to chicken nugget production. KFC understands that customers have diverse tastes and preferences, which is why chicken nugget production accommodates various customization options. From different seasoning levels to unique dipping sauces, KFC offers a range of choices that allow customers to tailor their nuggets to their liking. This flexibility ensures that KFC chicken nuggets appeal to a wide audience, enhancing customer satisfaction and loyalty. Managing energy consumption and production costs is essential for the efficient manufacturing of KFC chicken nuggets. KFC invests in energy-efficient machinery and sustainable practices to reduce operational costs and minimize environmental impact. From optimizing cooking processes to implementing waste reduction strategies, these efforts ensure that KFC can maintain competitive pricing while delivering high-quality chicken nuggets. KFC embraces a culture of continuous improvement, regularly evaluating and refining its chicken nugget production processes. Customer feedback, employee insights, and performance metrics are integral to identifying areas for enhancement. By analyzing data and implementing changes based on feedback, KFC ensures that its chicken nuggets continue to meet and exceed customer expectations. Automation and robotics are increasingly integral to the bulk production of KFC chicken nuggets. Automated systems handle repetitive tasks such as mixing, shaping, and breading, enhancing efficiency and precision. Robotics technology allows for greater flexibility and scalability, enabling KFC to meet high demand without compromising on quality. The integration of automation ensures that every nugget is crafted with consistency and excellence. Food safety and hygiene are paramount in the production of KFC chicken nuggets. KFC adheres to strict food safety regulations and implements comprehensive hygiene protocols across all manufacturing facilities. Regular sanitation procedures, temperature controls, and employee hygiene training are essential components of the process, ensuring that every nugget is safe for consumption and free from contamination. The fast food industry is dynamic, with evolving consumer preferences and market trends. KFC remains agile in adapting its chicken nugget production to meet these changes, whether it's introducing new flavors, accommodating dietary restrictions, or enhancing nutritional profiles. KFC continually innovates to keep its chicken nuggets relevant and appealing. By staying attuned to customer needs, KFC ensures that its nuggets remain a top choice for fast food enthusiasts. Efficient logistics are crucial for the timely delivery of KFC chicken nuggets to restaurants nationwide. KFC employs advanced logistics strategies to coordinate the movement of ingredients and finished products, ensuring that each restaurant receives fresh nuggets promptly. This optimization minimizes the risk of delays and ensures that customers can enjoy their favorite nuggets without interruption. Looking ahead, KFC continues to innovate in the realm of chicken nugget production. Emerging trends such as plant-based alternatives, sustainable packaging, and personalized nutrition are shaping the future of fast food. KFC is investing in research and development to explore these trends, ensuring that its chicken nuggets remain at the forefront of the industry. By anticipating and adapting to future developments, KFC solidifies its position as a leader in the fast food landscape. The marvel of KFC chicken nugget manufacturing. From sourcing the finest chicken to employing cutting-edge technology and maintaining rigorous quality standards, the bulk production of KFC chicken nuggets is a testament to KFC's unwavering commitment to excellence. Every nugget that reaches your plate has undergone a meticulously orchestrated process designed to deliver consistent taste, quality, and satisfaction. We hope this behind-the-scenes exploration has deepened your appreciation for the effort and innovation that goes into making one of America's favorite fast food items.